3.3 Gametogenesis. The primary sex organs, the testes in the males and the ovaries in the females, produce gametes, that is, sperms and ovum, respectively, by the process called gametogenesis. In testes, the immature male germ cells, which is spermatogonia, produce sperms by spermatogenesis that begins at puberty. The spermatogonia, which is singular spermatogonium, represent on the inside wall of seminiferous tubules multiply by mitotic division and increase in numbers. Each spermatogonium is diploid and contains 46 chromosomes. Some of the spermatogonia, called primary spermatocytes, periodically undergo meiosis. A primary spermatocyte completes the first meiotic division, which is reduction division, leading to formation of two equal haploid cells called secondary spermatocytes, which have only 23 chromosomes each. The secondary spermatocytes undergo the second meiotic division to produce four equal haploid spermatides, which is given in figure 3.5. What would be the number of chromosomes in the spermatides? The spermatides are transformed into spermatozoa, which is sperms, by the process called spermiogenesis. After spermiogenesis, sperm heads become embedded in the Sertoli cells and are finally released from the seminiferous tubules by the process called spermiation. Spermatogenesis starts at the age of puberty due to significant increase in the secretion of gonadotropin releasing hormone, which is GnRH. This is, if you recall, is a hypothalamic hormone. The increased level of GnRH then act at the anterior pituitary gland and stimulate secretion of two gonadotropins, luteinizing hormone, which is LH, and follicle stimulating hormone, which is FSH. LH act at the Leydig cells and stimulates synthesis and secretion of androgens. Androgens in turn stimulate the process of spermatogenesis. FSH acts on the Sertoli cells and stimulates secretion of some factors which help in the process of spermiogenesis. Let us examine the structure of a sperm. It is microscopic, a structure composed of a head, neck, a middle piece and a tail, which is given in figure 3.6. A plasma membrane envelops the whole body of the sperm. The sperm head contains an elongated haploid nucleus, the anterior portion of which is covered by a cap-like structure, acrosome. The acrosome is filled with enzymes that help fertilization of the ovum. The middle piece possesses numerous mitochondria which produce energy for the movement of tail that facilitates sperm motility essential for fertilization. The human male ejaculates about 200 to 300 million sperms during a coitus, of which for normal fertility at least 60% sperm must have normal shape and size, and at least 40% of them must show vigorous motility. Sperms released from the seminiferous tubules are transported by the accessory ducts. Secretion of epididymis, vas deferens, seminal vesicle, and prostate are essential for maturation and motility of sperms. The seminal plasma along with the sperm constitute the semen. The function of male sex accessory ducts and glands are maintained by the testicular hormone, which is androgens. The process of formation of a mature female gamete is called oogenesis, which is markedly different from spermatogenesis. Oogenesis is initiated during the embryonic development stage when a couple of million gamete mother cells, which is oogonia, are formed within each fetal ovary. No more oogonia are formed and added after birth. These cells start division and enter into prophase 1 of the meiotic division and get temporarily arrested at that stage, called primary oocytes. Each primary oocyte then gets surrounded by a layer of granulosa cells and is called the primary follicle, which is given in figure 3.7. A large number of these follicles degenerate during the phase from birth to puberty. Therefore, at puberty, only 60,000 to 80,000 primary follicles are left in each ovary. The primary follicles get surrounded by more layers of granulosa cells and a new theca and are called secondary follicles. The secondary follicles soon transform into a tertiary follicle, which is characterized by a fluid-filled cavity called antrum. The theca layer is organized into an inner theca interna and an outer theca externa. It is important to draw your attention that it is at this stage that the primary oocyte within the tertiary follicle grows in size and complete its first meiotic division. It is an unequal division resulting in the formation of a large haploid secondary oocyte and a tiny first polar body